Welcome to Context Window, your weekly look at the bleeding edge of AI coding tools. Let's see what's new.
All right, the AI tooling radar begins with big news from OpenAI. Some quiet updates to Codex were observed last week.
Indeed. It wasn't a splashy announcement, but developers are reporting noticeable improvements in context window handling for larger code bases, particularly for Python and JavaScript.
So, better memory for those sprawling projects. Why does that matter?
Precisely. It reduces the need for constant reprompts and allows the model to maintain a more consistent understanding of the overall architecture. For developers, that means less time correcting AI hallucinations related to forgotten context. It's a subtle but significant productivity gain for complex tasks.
Next, on GitHub Copilot, there's been chatter about a new explain code feature in beta.
That's right. It aims to not just generate, but also interpret existing code snippets. The idea is to make onboarding faster for new team members or help developers decipher legacy code without diving deep into documentation.
An interesting move. So it's about understanding what the code does, not just how to write it. If it works reliably, it could significantly cut down on the cognitive load of code comprehension. But the accuracy will be under intense scrutiny, given how notoriously difficult code explanation can be.
Absolutely. And speaking of comprehension, Google's Gemini code assistant has been flexing its multimodal muscles. Reports suggest it's now integrating better with visual diagrams and architectural blueprints, allowing developers to prompt with images and get code suggestions based on those visual inputs.
That's a fascinating development. It suggests a move beyond pure text to code, bringing in a visual dimension. What's the implication?
It could bridge the gap between high-level design and actual implementation. For engineers, being able to simply sketch out an idea and have the AI start generating code or suggest patterns based on it, rather than painstakingly describing every component in text, is a significant leap. The challenge, of course, is the fidelity of that translation from visual intent to functional code.
And finally, a quick nod to Cursor. They've rolled out enhanced refactoring capabilities, moving beyond simple syntax fixes to more structural code improvements.
Yes, this is about code quality and maintainability. Cursor is attempting to intelligently identify and suggest improvements for things like redundant logic or inefficient algorithms, not just formatting issues. It's an attempt to move the AI from a coding assistant to more of a coding mentor. The key question is how often its improvements genuinely align with best practices versus introducing unwanted complexity.
This entire discussion around AI and code generation leads directly to a rather unsettling warning from the ACM. They've recently flagged what they're calling systemic failures in AI coding, cautioning against something quite evocative: vibe coding.
That's the phrase that really captures it. The report suggests that AI systems, at their core, do not understand code in the way a human developer does. They're not reasoning about semantics, intent, or the underlying logic. Instead, they're performing what the ACM describes as superficial pattern matching.
So it's like a student who can perfectly mimic answers from a textbook without grasping the concepts. The code looks right, it might even pass some tests, but the AI fundamentally doesn't know why it's right.
A very apt analogy. The ACM's position is that this reliance on statistical correlation and syntactic fluency without true semantic comprehension leads to brittle code. This brittleness implies a lack of robustness, a tendency to break when faced with edge cases or novel inputs that deviate slightly from the training data.
This concept of vibe coding, where the AI just gets the feel of the code without understanding its purpose, sounds incredibly dangerous when you think about real-world applications. What are the immediate risks the ACM is highlighting here?
The primary concern is the creation of subtly flawed code that appears functional at first glance. Imagine an AI generating a security patch that looks correct but has a hidden logical flaw, or a piece of financial software that calculates perfectly for standard cases but introduces errors under specific, unusual conditions. These aren't syntax errors. They're deeper, semantic failures that are much harder to detect through automated testing alone.
So it's not just about the code breaking, it's about it appearing to work correctly while being fundamentally compromised or inefficient. That's a much more insidious problem.
Exactly. The report emphasizes that AI models are brilliant at generating code that is syntactically correct and statistically plausible given the context. They achieve fluency, but not necessarily competence. This creates an illusion of understanding. A developer might prompt for a complex algorithm, and the AI produces something that looks like it should work, but it lacks the deep logical coherence a human would build in.
And that's where the term systemic failure comes in, rather than just isolated bugs. It implies a deeper, more pervasive issue across the entire development pipeline if there is too heavy a reliance on this kind of AI output.
That's a crucial distinction. The ACM isn't just talking about individual errors. They're warning that if this superficial pattern matching becomes the norm for code generation, a fundamental degradation in software quality could be observed, leading to widespread technical debt, increased maintenance burdens, and a higher risk of critical failures across various systems. It affects the entire ecosystem.
This brings up the question of security. If the AI doesn't genuinely understand what it's writing, how does that impact the potential for vulnerabilities, either accidental or even intentionally malicious?
The security implications are profound. An AI that vibe codes could inadvertently introduce subtle vulnerabilities. For instance, it might generate a function that appears to sanitize inputs correctly, but misses an obscure edge case that a human expert would identify. Or, in a more concerning scenario, if the training data itself contains vulnerabilities or patterns of insecure coding, the AI could perpetuate or even amplify those issues in new code.
Concerns are already emerging about supply chain attacks in open-source software. Could this vibe coding make those types of attacks even more difficult to detect?
Potentially, yes. If AI-generated code is integrated into critical systems, and that code contains latent flaws due to its superficial generation, it becomes a new vector for attack. The code might pass initial scans, but the underlying logic could be subtly exploitable. It's like building a bridge that looks structurally sound on the surface, but has hidden weaknesses in its foundational design, because the architect didn't truly grasp the principles of stress distribution.
Beyond the immediate security and reliability risks, what about the long-term impact on human developers? If developers become too reliant on vibe coding, does it lead to a de-skilling effect?
That's a significant concern raised by the ACM report. If developers increasingly lean on AI to generate large chunks of code, there's a risk they might not engage with the underlying logic as deeply. The critical thinking, problem-solving skills, and the ability to reason about complex systems could atrophy. Developers might become more like AI prompt engineers than true architects or problem solvers.
So instead of enhancing human capabilities, it could potentially erode them by reducing the need for genuine understanding.
Precisely. The report doesn't suggest abandoning AI coding tools, but it strongly advocates for an approach where human oversight remains paramount. The AI should augment, not replace, deep human understanding and critical review. It becomes a powerful co-pilot, but the human remains firmly in the captain's seat, responsible for navigation and safety.
This suggests that current metrics used to evaluate AI code generation, like how fast it writes code or passes unit tests, might be insufficient. New ways are needed to assess the quality and robustness of AI-generated code, not just its superficial correctness.
Absolutely. The ACM report hints at the need for more sophisticated evaluation metrics that go beyond syntactic accuracy and basic test coverage. This could involve formal verification methods, where code is mathematically proven to meet certain specifications, or new types of static analysis tools designed to detect patterns indicative of vibe coding errors. The industry needs to develop tools that can probe deeper into the semantic integrity of AI-generated output.
So what does the ACM propose as a way forward? Are there any concrete solutions or mitigation strategies they outline to combat this systemic failure?
The report calls for a multifaceted approach. Firstly, greater transparency from AI model developers about the limitations of their systems, particularly regarding semantic understanding. Secondly, and critically, a renewed emphasis on human expertise and rigorous review processes. This means developers must act as vigilant auditors of AI-generated code, not just accepting it at face value.
It sounds like a call for a more informed and skeptical approach from the development community.
Exactly. They also suggest exploring research into AI systems that can reason about code more deeply, perhaps integrating symbolic AI methods with current statistical approaches. The long-term goal would be AI that can not only generate code, but also explain its logic and prove its correctness. Until then, the message is clear: trust, but verify, and understand the fundamental limitations of the current generation of AI coding assistants.
This has been a really illuminating discussion about the subtle dangers lurking beneath the surface of AI-powered coding.
It's a critical warning, reminding listeners that speed and apparent fluency are not substitutes for genuine understanding and robust engineering principles.
So for listeners, the key insights from the ACM's warning about vibe coding seem to be: first, AI models generate code based on superficial pattern matching, not true semantic understanding.
Second, this leads to brittle code with hidden flaws, increasing systemic risks in security and reliability.
Third, over-reliance on these tools can lead to a de-skilling of human developers, eroding critical thinking and problem-solving abilities.
And finally, rigorous human oversight, advanced verification techniques, and a skeptical approach are essential to mitigate these risks.
All of this prompts the question: is there an acceleration towards a future where code is written faster than it can be truly understood or secured?
That's all for this episode of Context Window. Join us next time for more on the AI tools shaping how we build software. If you're building with AI, subscribe. We cover what matters.
Ship smarter, not harder.